Yes.
All right, guys, good luck. Let's rock and roll. Hi there, good afternoon, everybody. It's Wilhelm Swart here from BluESP in South Africa. BluESP is working remotely. Everything is safe and fine, and involved with various, activities. Just maybe a little bit more about myself. So I lead BluESP. I'm an electronic engineer, and I've about 25 years worth of experience in mining and in industry. So what we're presenting right now is our Smart Focus 2020 webinar series, and really, as we are basically in the phase that we are right now in this new norm, and also with the lockdowns that's happening in various places and also in the economies, there is a lot of new focus, and so there's a lot of focus on working more remote, so less eyes on site and ears in operations. The requirement for more agility, doing projects faster with quick turnarounds, more focus on data analytics, and more using the power of the cloud of the cloud to process things, more embedded AI in the software where required. And so forth. Also focused on more collaboration between vendors and between companies and clients and so forth. Even a concept that we're seeing more and more right now is the concept of a virtual remote operating center. So the clients are saying, listen, how can we remotely monitor assets better? We want to monitor our crushers and our mills and our pumps and our fans and our trucks remotely and do some predictions on that. And also on the same matter, basically, be able to do some remote process monitoring and understanding, how can I make process parameters available to the specialists when they are away in lockdown. So what we're trying to do with this specific webinar series is to cross-skill and upskill our clients on these various intelligent technologies that we represent, and really to understand how they can run their assets and their operations and their processes safer and greener and faster and longer. So if you look at the slide, you can see we've got a whole host of technologies basically focused on. Last week we started with advanced process control, and really our teams are focused on projects on how to make the boiler yield 10% better, or how to save the chemical dosing on a process plant by 20%, or how to improve energy or the throughput or the quality of production, and that's all about advanced process control. You saw great presentation from Dr. Kevin Brooks last week. That event is recorded. You can still go and consume it, look at it again. All these events is recorded. And there is more one on the 17th of July. You'll see there's another session basically planned. Today we're going to start, focused on asset performance management, and look at the aspentech MTell technology and how that brings value in the sense of, so our team, the team that is here presenting, has been involved in various large mining projects with MTell in South Africa, Botswana, and also globally. And so I'm sure they will have a very good story to tell about what we can do. And then, next week we do MES, the first session on manufacturing or mining operational management systems, or industrial MES type systems, and also hear from Henny and the team, how do we focus with these technologies to run operations better. So what I want to try and depict on this slide is really, we're introducing the key operational technologies from 4Sight that enables our Enterprise 5.0. So what we believe is that if you take data and intelligent technologies and you bring them together, you basically get an intelligent enterprise, and that's what we're basically driving on. But it's not just basically data and technologies. People, and new business models also play a very big role in that. So yeah, it's quite important. So if we look at the type of technologies that we offer as a group, and here in the middle, now it's a combination of latest, greatest from various vendors. IIoT, so Industrial Internet of Things technologies, and from the aspentech suite, they're bringing a lot of AI and machine learning and deep learning into the software sets that they've been deployed for many years. Advanced analytics is the order of the day. We're using technologies like multivariate analysis to look at complex data sets and to do predictions and to grow models without the necessity of very, very smart data scientists to do that. And things like simulation, digital twins is highly required as well. How do we use virtual reality and augmented reality to enable the workforce better? And always you have to constantly be in handshake with your ERP, your SAP systems, your Sage, whatever you have at ERP level, so those are the type of things. So if we look at the specific picture and we start here from the bottom, so really, firstly, we take this enterprise, and we connect. So we connect instruments to the assets, we basically communicate that data up to control layers, do some control on that, make those assets safe, and visualize that in SCADA systems. Now, that part is very much done by our asset automation group, ACE Technologies, which is also based in Johannesburg, and they are a multi-vendor operator that focus mainly on plant automation systems using the likes of Siemens or Schneider or Rockwell or whatever, and we work very, very closely with them because every client normally have 2 or 3 different vendors that they basically work with. So as we then move up the stack, then we take the data from those automation systems and we transform it. So we aggregate it into information, and then we add more value with some of these intelligent technologies, turn it into knowledge, add wisdom to it, and ultimately, feeding more business intelligence. So that's the space of BluESP, the business that I'm leading. We very much focus on asset automation. We're a reseller and an ISP for Aspen Technologies, and I'll tell you a little bit more about that. But in between all of this, it's also very important to continuously think about focus on constraint simulation of, for example, your mining or your industrial processes. Or, for example, something like, focused on optimizing and your planning and your scheduling through simulation, and then using that simulation to control it. And that is again done by another group in the 4Sight group, Simulation Engineering Technologies, a bunch of 25 industrial engineers also here based out of Johannesburg, working very, very closely with us, so bringing that digital twin wisdom into our visions as well. So that gives you an idea of what we do. If we go a little bit deeper into, BluESP specific, the company that I lead. So how we see ourselves is a very agile company, and a company with multidisciplines. So we've got a bunch of chemical engineers, mechanical engineers, electrical engineers, data scientists, all working together, providing value to our clients. We use aspentech as our role models, and we basically use the intelligent technologies to bring value to clients. Now, the type of technologies, when I talk about intelligent technology, so they use things like embedded AI, machine learning, deep learning, basically now in all their disciplines. So they bring it into advanced process control. We will show you later in the series a bit more how they do that, but they're also in MES systems. They start using that right now as well to work those data. And also you'll see a lot of that today in this asset performance management presentation of today. And so if we look at the technology sets that's basically available from aspentech, so the first one is the design technology. So really focused on how do I design greener and more sustainable plants. So if I was building a new plant right now, I want to run it optimal, and that's what we do there. So they focused on things, so there's a whole set of tools there that helps you to simulate a complex process, design it, cost it, and build it to its optimum point. Really the EPCs, the largest EPCs of the world, uses a lot of that technology. Then the next one up is the operational technologies from aspentech. And so really we're focusing very much on how do we aggregate the data and turn it into information and store it. So if I have 500,000 tags that I want to bring up and I want to store away for in less than a second, and how do I aggregate that into information? I'll use historians. We'll use manufacturing execution systems or mining operational management systems to bring value to that data, to basically enable your operations, to get a enterprise-wide reporting, or look at the water balance or the energy balance, or the method accounting associated with it. Last week, for example, we focused on advanced process control. So how do I optimize my throughput if I have plants with large amounts of PID loops? How do I optimize? How do I orchestrate that? And how do I even orchestrate different plant sections with each other? So very, very interesting, and more of that will come in our webinar series. But the focus of today, we're moving to asset performance management. And so really, there we have 3 sets of technology. And today we're going to focus on the first set here, the machine learning technology, that focuses on predicting and preventing asset failure. So MTell is the topic of today. 2 weeks or 3 weeks from now, we're also talking about another set of technologies, the promv, that focus on predicting and preventing process quality failures. So the first one, we're focusing on assets, and then we focus more on processes and how do we basically control the quality and the throughput of what happens in a specific process. And then there is also simulation technologies in that same group that we can basically do a simulation on maintenance risk and maintenance reliability to see what the impact is. So yeah, so that gives you an idea of what we are focused on as a group. So what I'm going to do right now is I'm going to hand over to the leader of our asset performance management group, Koos de Tooy, to just tell us a little bit about himself and also to introduce the speakers of today. Koos, over to you.
Thank you, Willem. Yes, good day, everybody. As Willem said, I head up the APM team. My background is predominantly in electrical engineering and automation. Worked in oil and gas, food, bev, and various mining metals industries. Before joining BluESP in beginning of 2019, I was with Schneider Electric for 8 years. Last 5 years there was as a solutions architect in metals, mining and minerals. Worked extensively in Southern Africa with various mines, as well as in cement, in terms of energy optimization and so forth over in Africa. My 2 presenters today, I would like to introduce first of all Raisa, chemical engineer. Previously, she was with ArcelorMittal, studied at Stellenbosch, and she joined us in the beginning of this year, and she hit the ground running with MTell for a large mining customer. So she quickly picked up the pace, and she's ready to share with us what she's learned so far. And then Kinesh, he's got a master's degree in mechanical engineering from University of Pretoria. Specialist in gas turbine aerodynamics. He joined us in 2019. Previously, his function as a design engineer as well as a data analyst consultant from Deloitte. And since joining, he's been involved with predictive maintenance in energy and chemical space as well as in mining, and then also multivariate analysis in the steel industry. So with that, I'm going to jump over to what we're basically discussing today. So first of all, Raisa is going to introduce us basically in terms of in terms of asset optimization strategy and the success criteria surrounding that. And then we're going to jump over in point 2 to basically why do we consider prescriptive maintenance? Why would we want to go that route? And if we do, what do we need to consider? Then Ganesh is going to deep dive a bit into the value of prescriptive maintenance, specifically in mining metals and minerals. For our other members, though we're deep diving M today, we can address any of your questions, and there's also use cases in the various other segments. So it's just that we're zooming in on mining today specifically. Then from there, we're going to look at the value of early warnings and what MTell brings to us in terms of automated data workflow, the overall end-to-end solution from MTell, and then also review some of the assets in mining that's been done with MTell so far. Then we're going to specifically look at some case studies, and then we're going to open it up for questions. So with that, I'm going to hand over to Raisa. She can take us further.
Thank you very much, Koos. Hi everybody, I'm Raiza Khan, and I will be taking you through the introduction and why should you adopt prescriptive maintenance. APM is at the center of any robust operation. The APM suite that is available, it has the capability to optimize an operational asset, to extend the asset's life, reduce lifecycle costs, and thus ensure availability. It goes well beyond simply identifying fault-orientated maintenance requirements. We also offer, like Wilhelm has said, multivariate analysis and reliability simulations to predict asset performance. Asset performance management success criteria. So in order for you to get predictive and prescriptive actionable insights, it takes three important inputs. The years of valuable data that is saved in your historian. Then you add in some analytic solution like MTell and a bit of domain knowledge, and then gone are the days of unplanned downtime. You are then in control of your asset. Next, we will talk about moving towards this prescriptive maintenance philosophy. So the evolution of asset maintenance strategies has given industry the ability to digitally transform the way maintenance is done. And it has equipped them with the power of knowing. So your earlier maintenance strategies included reactive and preventive maintenance, and these are still very widely utilized methods. But I think it's now time to ask yourself if acting too late and too early is working. With predictive maintenance, one will receive an early warning at the onset of the predicted failure, which will give you enough time to plan and strategize your maintenance. However, the step into the future consists of prescriptive maintenance. Simply put, prescriptive maintenance, it solves that frustration of don't just predict, prescribe a solution. It provides earlier and easier detection by detecting changes in your data to tell you what failure, when will it occur, why is it failing, but it takes it a step further and it recommends a solution. So to adopt prescriptive maintenance, an organization would need 4 important initial steps. You would first need to check your readiness. We will touch on this later on. Secondly is your proof of concept. To shift to this new way of thinking and convincing your workforce to adapt, I think would be a lot simpler if prescriptive maintenance software, MTell, is tested on a single asset, thus providing you with tangible results. So this will then give your end users time to gather the success data of the software and then literally see that this is the most cost-effective approach. Thirdly, we have solution scalability. So once you see the success of prescriptive maintenance from the proof of concept, you can then begin rolling out the solution. To do this, you would then need to prioritize your assets based on its ability to stop production due to failure, environmental regulations, and personnel safety. And last but not least is changing the culture. So changing the mindsets from reactive to prescriptive is a vital part of a successful maintenance strategy. Because regardless of the money that you spent, if your workforce is not willing to adapt, then you will likely see no improvement in performance results. Now, next, we talk about why should you choose prescriptive maintenance. So when trying to migrate to a prescriptive, sorry. Sorry, I'm just having a bit of technical issues. So why should you choose prescriptive maintenance? You would need to choose it. So most industries suffer from very high maintenance costs, and this can be due to the cost of spares, procurement of it, delivery of your spares. But with prescriptive maintenance, you have the ability to decrease your downtime. It allows you a lead time to make coherent decisions and gives you better utilization of your resources. Okay, next we will talk about the hurdles to overcome. So the hurdles that you would need to overcome, like anything, there are hurdles. But once you overcome them, the value it brings to your organization will make these seem minute. The first and most important being changing the workforce culture. So many in industry have this mindset of, if it's not broken, don't fix it. But it is vital to get every single person to adapt to the idea of early warning and solution recommendations. This change would need to take place throughout your entire organization. From finance and procurement, you would need to convince them to buy spares for an asset that has not yet failed. And then your artisans, because you would need to prove to them that by intervening before any sign of failure is actually the best approach. Next is the limited CapEx budgets, which are faced by most industries. And finally is the regulations. So some regulations do not allow for the traditional approach to be replaced by prescriptive maintenance. An example would be your required maintenance on, say, pressure vessels or PRVs. In cases like this, you would have to opt for scheduled maintenance to obey regulatory bodies. So now we will talk about, so most industries are at the point of predictive maintenance. So for effective predictive power of asset failures, there are 4 crucial requirements. So you would need your instrumentation, which all of you would have by now, your data sources, so your historian, your EAM systems, your OEM systems, your maintenance history and associated failure modes, as well as a reliability engineer or a subject matter expert who is familiar with the asset. So now that you have adopted predictive maintenance, you are almost there to take on prescriptive maintenance. You will just need to ensure that all asset knowledge is captured, whether it's your RCAs or findings during planned shutdown tasks. Next is proper workflow management. And finally is the prescriptive maintenance site champions. These champions can be involved at different levels. Your building phase, so configuration and agent building, your monitor phase, reviewing of anomaly or failure alerts, and then your ACT team. This is most likely your maintenance team that will react to your alerts. And I now hand over to my colleague Kinesh.
Thank you, Riza. Hello, everyone. Today I'll be speaking about the potential for prescriptive maintenance in the AAM industry, and I'll also give you an overview of the solutions that exist at the moment. So what is the opportunity that lies in the mining, metals and minerals industry? Well, for starters, the industry is quite asset intensive, and that presents a lot of opportunity to transform your maintenance function from a cost center to a value center. And these things are all coherent with the technology that you use in your organization. And without this technology, you won't be able to connect your people to your plant or your plant to your processes, and from your people to your processes. And some of the advantages and the opportunities that lie within prescriptive maintenance, and including Industry 4.0, is able to monitor your assets remotely and provide decision support to your plant, even though you aren't on site. And it will also allow your workforce to identify critical problems much faster and solve them much faster. And in essence, you will be able to increase your safety, protect your environment, and also contribute towards sustainability and continuity of your workforce. And at the end of the day, the competitive advantage from adopting this technology will give you the greatest leap ahead, far greater than any financial value that you can receive. At the same time, your enterprise will also have visibility on all its assets, and the utilization of these assets will also contribute to the return on investment. And transforming your maintenance function also includes faster turnaround times on work requests. You can manage and reduce your operational risk. So if you see any risk coming up in terms of assets and downtime, you're able to plan accordingly. And lastly, you also find that you'll achieve operational and engineering synergy. And what I mean by that is there's usually always an offset between production and engineering or production and maintenance. And this is where you can see the balance starting to fall into place. And at the end of the day, you'd be able to protect your value chain, whether it be in mining or metals or minerals and any other industry, for example. So where do we start with creating value with prescriptive maintenance? With Industry 4.0 and machine learning and artificial intelligence, we can extract value from years of historical data and learning what happened in the past, how did this happen and why did it happen. We can identify when and how to avoid future events from occurring. And this will also help your workforce to maintain continuity, because as we see in industry, there's a lot of turnover and people tend to move on as well as retire. And we have a new workforce that comes in every generation. And the knowledge that is captured from these generations from one to the next is a powerful entity within any organization. And specifically in prescriptive maintenance, this will allow you to capture all the information that's done in the past regarding root cause analysis, equipment criticality analysis, as well as your fault mode, effect, and causality. At the end of the day, we're also enhancing safety because we continuously monitoring our assets. And most of us know that safety incidents always occur during startup or shutdown. And when you have eyes on all your assets at 24/7, you're able to see these safety incidents coming and able to act accordingly. Prescriptive maintenance also allows you to optimize your planned maintenance activities. And using a data-driven approach, you can actually reduce the amount of planned maintenance activities that exist in your organization. Some examples we see in industry is that some plants and some of their maintenance functions are only able to get to 20% of their scheduled work orders, and the rest remains just in a pile. Prescriptive maintenance can help you identify which work orders are the most important and also allow your workforce to be utilized more effectively. And in that saying, your increase in plant availability will become evident as you're tackling the problems that are causing your downtime the most. You're also able to extend your asset life, meaning that your return on investment on the assets that you purchased are able to give you more value for money. And lastly, efficient planning. Having an optimum workforce as well as your spares utilization will ensure financial well-being in the long run. So what is the real enterprise value? Time to plan around these predictive failures. If you look at any organization, you will see that having more time to plan means having more time to make the right decision. And this will impact all the chains along the value stream, from planning and scheduling, production and feedstock, to even your inventory and sales. And lastly, your maintenance function will be centered around all of this. At the end of the day, you're able to reduce a lot of your operational costs, maintain your safety and revenue, and also increase employee effectiveness. Now I'll provide an overview of Aspen MTell prescriptive maintenance solution. So Aspen MTell was designed based on the reliability engineering. And if we look at the reliability curve, which is the probability of failure, most solutions always sit in between the point where damage has already occurred or failure is bound to happen. And this is where Aspen MTell is a differentiator in the market. MTell is able to provide an extra lead time with much earlier detection of potential failure, and it does this by looking at a wider net of sensors. Most prescriptive maintenance solutions only look at what's happening on the equipment itself, whereas MTell is able to look upstream and downstream and give you a wider net of sensor data that's able to predict the potential of these failures from occurring. The value of early warning is the basis of MTell. Catching these small failures before they become catastrophic is the most important part of this process. If you're able to see these patterns developing much earlier in its stages, you're able to do something more effective to either stop it or prevent the damage that will occur. When Aspen MTell alerts quite early, you will see that this potential failure can be avoided. And there are two levels of action in which you can take. The first action, which is the most common, is to reduce the downtime and the equipment damage. And this would be done by scheduling maintenance in order to correct the problem. The second level of action is much more sophisticated, and more prescriptive value is gained from this. Here you're able to avoid downtime completely, as well as save the equipment from failure. And the ability to do this is to apply operational changes that move the equipment away from the failure stage. So MTell is a commercial software which allows you to automate a lot of the data science so that your reliability and maintenance engineers are able to focus on solving the problems that they can use their domain knowledge with. As you can see from the diagram, Aspen MTell is comprised of a number of automated data workflow wizards, and these allow the engineer to basically design, build, deploy, and monitor any failure mode that they can find. And they do this by connecting to the historian, to the maintenance system, and then they allow the engineer to actually select the sensors, identify the problems that they're looking for. They can also look at the failure events by looking at the maintenance history. And lastly, they can train and test the failure prediction. And in machine learning terminology, this software allows an engineer, such as a reliability or maintenance engineer, to do feature engineering and feature selection. And all of this becomes bundled up into what they call autonomous agents. These autonomous agents basically just predict and prescribe failure pattern recognition. And what they do is they're able to detect unique failure signatures with multiple failure modes, as well as cascading failure modes, where you see one failure leads to the next. It's also able to detect early stage failure by looking at a wide range of patterns. The second part of these autonomous agents is abnormal pattern recognition, or what they call in industry anomaly detection. With this autonomous agent, you're able to detect new failure modes when they present themselves, as well as detecting new operating states that exist in your operations. So what is an autonomous agent? On the screen, you will see a visual aspect of what an autonomous agent is able to do. By combining your plant data with your mechanical and process information, as well as overlaying your maintenance information of when failures occurred, when you did planned maintenance or cleaning activities, the autonomous agent is then able to transform this data into a probability waveform, i.e. probability of failure. And when you start to see increase in probability of failure, you know when to do something about it. And this methodology also takes care of the variation in your data, whether it be seasonal conditions, different operating campaigns, as well as startup and shutdown conditions and different wash cycles, for instance. In an end-to-end solution, Aspen MTell provides a range of functionality. From the machine learning to failure patterns and abnormal conditions, the solution is able to plug into different data sources such as your historians, as well as your maintenance systems, commonly known as your enterprise asset maintenance management systems or computer maintenance management systems. And this is where you start to overlay your maintenance history with your historical process or mechanical data. And with the interfaces provided, you're able to one-click and retrain your agents to predict these failures. There's also prescriptive responses built into the system, which is able to write back into your maintenance system When you receive an alert, you're able to prescribe a work order or prescribe maintenance activity that needs to be done. And these are also provided by emails and SMSs, which are sent to designated engineers and people that will take action and investigate. On the overall solution, there's also a live web-based dashboard, which allows you to view all the assets that you're monitoring in real time. And you can also prescribe work and generate work from this dashboard. And one of the fundamental aspects of MTell is the scalability, or transfer learning as it's known. And this ability allows you to scale your visibility on assets by transferring models or agents that you built on one asset to other similar assets, as you can see in the example. So Aspen MTell is able to work on any asset. And these are some of the examples that we have applied MTell in industry. And these are critical to the value chain and allow organizations to maintain the productivity as well as safety. Because Aspen MTell is a data-driven approach, it is also OEM agnostic, meaning that it works on any type of equipment. We also have adapters that are built in to feed different OEM systems so that you can monitor those systems in conjunction with your historian. It's highly scalable, meaning that you can transfer a lot of your learnings from one asset to another similar asset. And this works well for mobile equipment, where you've got fleets of similar equipment and similar failure modes, but you don't necessarily have to train a model for each one. You can train on one and transfer to all. It also allows for maintenance integration, so that whenever you have any alert, you can prescribe a work order, which will allow for maintenance to take action. And because it's a data-driven approach, any failure mode can be detected with this technology. Some of them are mentioned in the examples here on the screen, but based on the data that you have available, the sky is the limit. If you can see it happening in the data, or if you can't, MTell will allow you to predict those failures with the early lead time. Now we'll go into some case studies where Aspen MTell has been applied in industry. In this first case study, we'll demonstrate how MTell has been applied in steelmaking, and particularly in a plate mill motor generator set. In this example, a generator bearing failure was predicted with 17 days of lead time. Now in a plate mill, a motor generator set is used to control the speed, which is also used to control the slabs, which are passing through the plate mill. And this is critical for real-time processing because the temperature and the speed at which you process these slabs ultimately determines the production quality as well as the productivity of your plant. So these bearing failures occurred in succession, as you can see in the example. And the repair cost is quite low in comparison to the production loss, which is quite high. If any of these bearing failures occurred while they're producing, it would force them to actually get rid of that piece of the slab and actually have a production loss without having the ability to recover from this. So with 17 days of lead time, this will allow your maintenance team to plan around this and allow the schedule and allow the maintenance to be done, which doesn't impact your production. And the ease of the software allows you to build these type of agents within a couple of days. In this particular example, we built this agent within 2 days with the reliability and maintenance engineers because we had the right information, we knew what we were looking for, and we're able to demonstrate that it will give an early lead time. And overlaid on the picture, you'll see the sensor trends. And the methodology of Aspen MTell is it looks for patterns that humans can't see. And the visibility of these patterns is not always easy to see something approaching a failure. And that's where the power of machine learning comes into play. It will do all the heavy lifting for you, so you don't have to worry about what the data is doing. You just need to tell MTell where to look, and it will tell you when you're approaching a similar scenario. In our second case study, we'll look at a turbine generator used in power production in a steam power plant. In this particular example, we predicted a casing crack failure with a steam leak with a lead time of 24 days. Now, as you know, steam generators are quite highly critical and high value assets. And the production of electricity is to compensate for purchasing electricity. So any downtime associated with this equipment ultimately leads to additional electricity costs as well as a production impact if you aren't able to compensate for the downtime. In this example, we predicted a steam leak, which was due to a casing crack, which had occurred due to a planned maintenance activity just before that. And the reason for this is the casing was incorrectly fastened, and this resulted in increased vibrations on your casing, your bearings, as well as the steam pressure that changed. And over time, this crack started to propagate, and we could detect this signature using a combination of mechanical and process sensors. And as you can see, we've used turbine casing expansions, exhaust steam temperatures. We've even got some flows of the steam. And that's the power of MTell, is that it doesn't only look at your mechanical data, which is common in industry for vibration monitoring, for example. We also combine this with the power of process data, looking at what's happening to the process when equipment is failing, and also what's happening to the equipment when the process is changing. In this example, 24 days lead time is a significant benefit, because the large equipment like this often requires a lot more planning and scheduling of maintenance, ordering of spares, as well as getting your production to account for the downtime. If you are able to see these patterns emerging quite early, you are able to also take more prescriptive action. And if you have a standby unit, you can prevent more damage to equipment by moving on to your standby unit. In this example, we built this failure agent in 1 to 4 days, and we use the reliability and maintenance engineers' knowledge and domain expertise to get the right signature using the right sensors, as well as the right maintenance information. Effectively, 24 days lead time would have led to correct fastening of the turbine casing, and this would have avoided the failure altogether. So I've only been speaking about failure agents, but what about anomaly detection? In case study 2B, we look at the same turbine generator, but here we look at anomaly detection on the lubrication system. And what happened here, there was a malfunction of the lubrication system during a power disruption. And when the power came back, the lubrication system failed to start up again, and the operations continued to run without anybody knowing. So with anomaly detection, we're able to learn precise signatures of normal data, and we basically tell the software to look for abnormal pieces of data, whether it be changes in startup or shutdown, or just general operating conditions. And what you can see there is that just before the failure, the change in operating state gives a good indication that something is different with a couple of alarms. And what we're able to do with MTell is we're able to create a failure agent from this prediction. And this is the power of anomaly detection as well, is that we can create new failure agents to account for new failure modes. If you look at the sensor data or the sensor trends of these bearings, you will notice that to the human eye, this looks quite normal or nothing out of the ordinary. But with machine learning, you're able to see the precise changes in temporal events that the human eye would normally not see as abnormal. And with the failure agent, we were able to predict this failure with 8 days of lead time, meaning within those 8 days, the maintenance team could have been instructed to do an investigation and find that the lubrication system wasn't functioning correctly. And this led to bearings, seizing, and overall electricity production loss. In the last case study, we'll have a look at mobile equipment. And one of the examples we have here is a continuous miner that operates underground, and sometimes in remote locations where maintenance personnel are not always available to do anything on the equipment until it's brought back to the surface. In this example, we looked at a small piece of the equipment or subcomponent, which is the cutter motors, which effectively do all the hard work. And what we found that we've also used a limited amount of sensor data, meaning we've only used our phase currents and our motor temperature. And we were able to predict a motor imbalance failure with 5 days of lead time. And again, in this example, we see that a planned maintenance activity led to these failures where the motors were not fastened correctly or there was damage to the unit while it was being installed. And in these scenarios, the repair cost and the production loss is high because it usually takes time to get this equipment back to the surface. And these equipment are quite advanced and very new, so they're also quite expensive to repair. With 5 days of lead time, production and maintenance could plan around this by having their fleet of vehicles take into consideration the downtime. And by that, I mean by substituting a different unit or changing the motor before it got to the stage. Another example is that transfer learning can be applied here. We can cover a full range of the fleet by using one agent without having to train a model for each one. And that's the power of machine learning with this agent-based methodology.
Right. I received a couple of questions. I've started addressing some of them, but we can review. So one of the questions was, what's the minimum period required, data required for the solution to consume? And the big thing there, it's a couple, you need a couple of weeks at least, because you need to be able, for anomaly agents, basically to have a period of normal that you can train the agent on. So also for, in the case, for instance, where you've got new equipment, this will definitely be the case. However, so you'll need a couple of weeks, but if you've got similar equipment that's existing, so for instance, pump set, which you've already trained and you know what normal behavior is, and you add a new pump without any history, we've got transfer learning, so we can apply that knowledge learned on the one pump over to the other pump, basically, because we know what normal behavior for the pump is. So that by that way we can mitigate that. Then there was a question, if you are using historical data to train the model, how would it be of value if a maintenance history did not identify the correct failure mode? So though the idea is to have autonomous agents, we obviously still, when you train these agents, you review the sensor that's associated with that asset. You review the behavior of those sensors during a failure or for a failure that you're training. So first of all, if it doesn't seem to match, you would then be able to ascertain why. Does that work order? Is it at the correct date? Was it recorded correctly? Does it need to be moved? Or is it purely that it's incorrect failure mode? Now, you can obviously adjust it then accordingly. Then the other thing is that you can also, even if you've trained it improperly, the associated workflow that you have with MTell. So if you do get an alert in the future for that deployed agent, during the pending investigation, that you find maybe that you did actually train it incorrectly, then with the interface that's available in the MTell workflow, you'll be able to either to select, if it's an anomaly agent, you'll be able to distinguish between normal and abnormal behavior, or on a failure agent, specifically in this case where we look at maintenance history, you'll basically be notified that you need to train or retrain the agent, which is a manual action back into MTell to ensure that you do accurately select the associated work order with the sensor behavior for that failure. And then just want to see then.
A question to.
Well, how would you?
Aisha.
Okay, yeah, I'm gonna. There was a further question here. Ganesh, you can take this one. So furthermore, does the solution have some kind of reinforcement learning functionality? In other words, the reward function can be, for instance, OEE, so overall equipment and the agent then explores solution space as it learns from the data. You want me to repeat that, Ganesh?
Yes, you can repeat it for me.
Okay, so does the solution have some kind of reinforcement learning functionality? In other words, the reward function can be, for example, OEE or a specific KPI, okay? And then the agent then explores the solution space as it learns from the data.
Yes, so when you deploy these agents live, if you receive an alert that is similar to a signature that you've learned in your training, you're able to classify these alerts on the fly. And that can be if it's a false alert, or if it was an operational change that caused this alert, or if it was a valid alert which actually was significant and you were able to prevent this failure from occurring. The agent is able to learn going forward, and it's always learning and continuously learning from what you tell it to do. So it's rather more dependent on the domain knowledge of the person that's actioning these alerts, as well as the training data that you've used. That will determine how precise and how accurate it is, and it will only get more accurate over time when it's classified correctly.
Okay, and then Raisa, so MTell is focused, is it only focused around rotating equipment, or can it be deployed on other equipment types as well?
MTell can be deployed on other equipment types as well. It does not necessarily just have to be rotating equipment.
Okay, and and we would basically, it depends on the sort of a sensor information available for that asset, more than if it's rotating or not.
Yes.
So generally so in mining we tend to find that regarding rotating equipment, we do have winding temperature information. We've got bearing temperatures and vibrations and so forth, which makes it easier on the rotating equipment. But in terms of switchgear, transformers, or even mobile equipment, trucks and so forth, it's just a question that we need a fair amount of sensors.
Chris, there's a question here where I think somebody's asking that do we use certain models or blueprints for specific equipment that we apply to that equipment, or do we grow the models using machine learning? So I think that's just, I don't know who can answer that one. Ganesh, like do we have a set of blueprint models that we basically follow, or are we actually learning it on the fly? Ganesh, you're just on mute there. Can you just unmute?
No, we do not use any blueprint models. What the software actually does is it's based off the historical data and maintenance data that you're able to feed into the tool. And then using the domain expertise and domain knowledge of your engineers, it relies upon the information that they train on the specific failure data that they classify as failure, and they also classify normal data. And it doesn't require any models. It's not based on blueprints. You don't actually have to know what the equipment looks like or does. You just have to know the points in the data that should be classified as failure and what should be classified as normal, and you're good to go.
Okay. I had here, how would you predict a failure where there's no training data? So I think that ties up to the previous one where we basically discussed if you don't have a lot of data. So with no training data, yes, you will not be able to predict any failures. But once again, with a couple of weeks worth of history, you would be, that's a big key. So as Ganesh mentioned before, you do need, doesn't necessarily have to be historian, but you need to have a period of history available, from a couple of weeks, couple of months, preferably, so that you can learn the behavior of a specific asset. so that you can train agents on that. Ganesh, do you use deep neural nets and or k-nearest neighbor? Also, how do you prevent overfitting when using deep learning?
So the software is actually built with a couple of algorithms, including the KNN. But what we see is with anomaly detection, we're actually using a classifier algorithm. And for deep learning, what actually happens is you can use multiple events to train, but there's always a good ratio to use of normal to failure. And that's usually 3:1 or 4:1, meaning for every failure that you train, you use at least 3 times the amount of normal data so that you don't overfit. But in special circumstances, you can train on multiple events in one go to increase the prediction and the accuracy. But that also depends on the data that you're using, whether you get in more precise signatures with vibrations, or if you're not using vibration data and you're using process data, then you might want to include more than one example, because we tend to see that some equipment operates in different states. So then you also need to identify, are you training for a specific failure that happened in state 1, for example, or are you training for the same failure that may have happened in state 2? So those are the things to consider. But like I said before, MTell takes care of your variation in your data. So it's also able to do the classification of normal for you. And then it also depends on how much of history you have and the granularity of your data. How frequently are you tracking your data or your instruments in the field? So when you have less history, you would preferably use a higher frequency of data, given that it's not too noisy. But ideally, we like to use at least 12 months of data if it's available, but we can use at least 6 months for anomaly detection to start with.
Right. So your equipment. Okay, equipment. What's it? What equipment should you monitor? So basically, you can monitor all your assets on a plant, but you would typically start from looking at it from a criticality point of view. So assets that's been identified as from a high, medium, and low criticality, in terms of cost or quality or throughput, depending on what it is that you look at from an operation. Then also your failures, the amount of failures that asset basically has. So also from a sort of a high to a low sort of, or a rare scaling. And then from a detectability point of view, that's the information available. So do you have history available for the asset to learn on? So those are the 3 sort of most important considerations when selecting an asset for predictive maintenance with MTell. I think, yeah, that's most of the questions.
I think, yeah, so just check if there's one last one that we missed. I think if we missed any, then we will just come back, so you can continue typing or texting questions, and we'll just get back to you individually. And
just one more.
Yeah. Yep.
Sorry, just a business model for execution. It's a question, but I think the question is basically thing for the software, is it, because the question is business model for execution is per equipment. So I think they're asking, do you pay for each asset individually? And the answer there is no. This is a site-based approach. So the software licensing wouldn't be based on the number of equipment that you want to monitor. It's a site-wide license.
Okay, so thank you, Koos, and I think a special word of thanks from me to Raisha, to Ganesh, and to Koos to basically share this knowledge with us. And like I was sharing the contact details before, you can type any other question, or if you in there, or if you want any of these 3 business consultants to basically contact you and to discuss your specific requirements a bit more, send us an email or send us a note or just type a question here and we will follow up with you. As you can see on the slide here, so this event is recorded, so you can share it with somebody else and they can still consume it tomorrow, next week, look at it, and you could refer back to it. Also, like for example, last week session on advanced process control was also recorded, and you can still go in that. So it doesn't matter when you register in the series, you can always refer back to a previous recording and interact with us. So you can see already on the right hand side there, the next event is next week, and we're focusing on MES in the cloud, and also Glenn and Henny will take us through that specific session. We during this lockdown phase, we also continue offering virtual training, virtual discussions with some of our consultants. So just reach out to us and we can at any time have a discussion with you on your training needs. There's, for example, a virtual training week, training this week, and 2 weeks ago there was also. So, we are fully operational. We are still completing various projects remotely and handing oversights in this lockdown period. So the beauty about where we are today with these technologies, you can continue and bringing value and have clarification meetings on projects in this lockdown period. Thus, with any further ado, I would like to thank each and every one of you for your attention and for spending the time with us, a whole hour with us, and we hope we added value. If there's more questions, let us know. Thank you, and with that we will end this session and hope to see you in future sessions. Thank you very much, everybody.